We're back for the second part of this video, sorry, so we'll try to keep it about 10 minutes like the other one. So number 8, a bug begins to crawl up a vertical wall, I think, at time t equals 0. The velocity v of the bug is from time t from 0 to 8 is given by the function whose graph is shown above. What value of t does the bug change direction? So let's look at what we got here. So number 1, we're given, so we've got velocity v. Okay, so this function here is, in this case, let's just go v prime of t. This is our velocity. Okay, so when the function bug changes direction, what this means, and this is pretty key too, when you change direction here, it means when your derivative goes from either positive to negative, or negative to positive. Okay, so that's what we have to look for. Okay, so we got to look at interpret our graph here. So as you can see here, it doesn't matter here. This is the v prime of t. So your derivative from time 0, your bug is moving right because the derivative is positive. Keeps going. It doesn't matter these sharp edges. It doesn't matter any of that stuff. This is the derivative function, and it's positive all the way to 6, and then you go into negative here. So at 6 is where we see a change from a positive slope to negative, and that means that is our answer. So our answer for number 8 is C. Okay, so let's keep going. Number 9. Okay, so if we have h of x, if h of x is equal to this, and I kind of highlight what I need. So here's my h of x function, and we need h double prime of 2. So there's a couple things we need here. So number 1, we're going to find h prime. So h prime of x is equal to 3x squared, okay, minus 2x, and that's going to be minus 1 over x squared. And you hear that noise, Mr. Bennett's got to make a quick pause. What's wrong, baby? Hold on. What? All right, and we're back. So here's our first derivative, and now we need our second derivative. I wonder how long this will last before my boy comes back in. Okay, so here's what we need. We're taking the second derivative, which becomes 6x minus 2 plus plus 2 over x cubed. Okay, and so what's that, Bubba? You want mouse? Oh, you want more pouch. Okay, more pouch. All right, hold on. Sorry, everybody. All right, so we're back again. Okay, so we're going to finish this one up, I promise. So we've got the second derivative now. Now it's a matter of substitution. Okay, so you have now h double prime of 2. So whatever you want for x has got to be now 2. Okay, so let's just be careful here when we substitute. So we're going to have 6 times 2 minus 2 plus 2 over 2 cubed. Okay, if you simplify that down, whoops, we forgot to put our 2 here, you should get 41/4. Okay, I'm going to assume my math is correct there, my derivative is correct. My answer choice should be E. Okay, all right, number 10, find the points of inflection here of this function. Points of inflection deal with second derivative. Okay, f double prime of x. Okay, possible points of inflection. So let's go ahead. We're going to take our first derivative here, and that becomes 3x squared minus 6x plus 2. It's a power rule. Then we're going to find the second derivative, so you go ahead and knock this out, which becomes 6x, okay, minus 6. And when you want to find points of inflection, we set our second derivative equal to 0. Okay, so then I'm going to factor out a 6 here, and I get x minus 1. So that means x is equal to 1. So if you were going based on the point of inflection, you would count out C, and you would count maybe out E. I'm going to say none of these. Okay, I'm going to count that one out. So sign analysis tells me that I better see a sign change here. Okay, so when x minus 1, well, if you plug in any number greater than 1, you get a positive number. Any number less than 1 is negative. So there is a sign change there. So 1 is a point of inflection. Now you need the y-coordinate. So you go back to the original, f of x, and wherever you see an x, you are going to plug in 1. Okay, so that's the key thing here, and so hopefully your algebra is okay. So I'm going to go ahead and plug in 1 now. Okay, so 1 goes here, 1, 1, 1. Okay, and so we get 1, okay, minus 3 plus 2 plus 15. Okay, by looking at that, you know that's not going to be negative 3. You know that's not going to be negative 1. So it's negative 2 plus 2 is 0, and that's 15. Answer choice is A. That's what happens when your wife goes out of town. Okay, got a couple problems left. Okay, sorry everybody for the interruptions, but it's cute. It's life. Okay, so here's our function f prime. So I'm looking at this. I haven't even read the problem yet, but I'm gonna pick out. I know this is f prime. Okay, so we know that we want to graph the graph of the derivative function. Okay, and I guess I want to keep highlighting stuff. This is the derivative of f is shown above. Which of the following are true about the original function? Okay, let's see what we got. So f is increasing on negative 2 to 1. So negative 2 to 1. Is that function increasing? So the argument could say, well, it's not increasing here. You have a negative slope, but then from negative 1 to 1, it is positive. It is increasing. Remember, f is increasing on the interval here when f prime of x is greater than 0. So from negative 2 to negative 1, back from a break because David was wanting some water. So agua. Okay, so we're back. F is increasing on the interval. I would say no, because from right here, guess what? Your derivative is 0. Oh, look, a face. We make a smiley. Okay. Is the function continuous at x equals 0? Yeah, if you look at 0 here, there's no problem. There's no sharp corner. This is the derivative, so if there was a problem here, there might be a hole or a point. But we look pretty good here, so 2 is in, I would argue. Okay, so if 2 is in, okay, this is out. It can't be this. It could be 2, and it can't be e, because 1 is gone. F has a point of inflection at negative 2. So I made a smiley face, but I need to look at negative 2 here. Let's clean this up. At negative 2, a point of inflection. Well, that means the point of inflection, that means your f double prime of x would have to change sign. Okay, so let's look at some slopes here. So at negative 2, okay, that would have to change directions, but also if we're looking at the derivative function, would the slopes here, whoops, that's not a great drawing, I'm sorry. Would the slopes here change direction? And I would argue that it's the 0 here, but you go from a negative slope to probably a positive, so I would say 3 is in 2, and so my answer is going to be 2 and 3 there. Okay, so your answer is D. Okay. All right, number 12, determine the critical points. This is a good one. Critical points, I'm going to highlight those. If f prime, now this is important, you already have the derivative here. You don't have to take this derivative, and I think that was like a number 3, something challenging like this. So all you need, whoops, is a sign analysis, but you have to be careful, okay, on this one, because it says determine the critical points if the derivative is this, okay. So you can test them. For this one, I don't always like, depends on your definition. Oops, okay. Of critical values, okay. Critical values are where your derivative of x equals 0 or your derivative is undefined, okay. So the critical values here, multiplicity of 2 would be x equals 3 and x equals negative 2. Those are the critical values. Okay, so these are your critical numbers, but you want to be careful. That doesn't mean they're actually maximum minimums. So negative 2 and 3, your answer there is A. They might be maxes and mins, but those are the critical points. Okay, and number 13 here. Okay, so the minimum value of our function e to the x is, okay, so when you talk minimum value here, you're talking derivatives, minimum. Okay, you're talking about derivatives. So f prime of x is equal to e to the x minus 2. Okay, and so you're going to set this equal to 0. Okay, and you're going to have e to the x minus 2. Okay, now this is a tougher one. E to the x is never going to be 0. Okay, but we're going to bring the 2 over. And so when does e to the x equal 2? Okay, so this is when you need some algebra skill. We're going to take the natural log of both sides here. So you're going to have the ln of 2 is equal to, now when you take the ln of this side, you're going to take ln of e to the x, which if you kept going, you'd say, okay, that's ln of 2 equals, now the x would come up front. Now you could stop above here if you needed to, because if you knew the answer, and that's fine. If not, here's just a couple other steps. So ln of e to the x, everybody, this is just 1. So you know that x is equal to the natural log of 2. Okay, so if you were going to do this, the minimum value, okay, there's only 1 0 here, so the minimum value is going to be ln of 2. Okay, it's not going to be this, 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 or this. Okay, if there's more than 1 0 here, I would say you would have to make a sign analysis, but in this case, skip it because there's only one value and it's going to have to be the minimum. Okay, so that wraps up the second part of this exam review. If you guys have any questions, please don't hesitate to ask. Hope you found it insightful and you got a little peek into my kids' life or the life of a dad. So anyway, have a good weekend, everybody, and we'll see you Monday.